Jai Hind to all. This is Chelsi Sen, Assistant Professor, IT Department, AKGC, Ghaziabad. Today we are going to start the series of DBMS in which we are going to discuss about the transaction processing concept. We had already discussed about the introduction and the SQL part. Today we are going to discuss what are the transaction and what are the various operations in this particular transaction processing. So let's first discuss about what is the transaction. Now, talking about the definition, the transaction is a set of logically related operations. It contains the group of tasks, group of operations. So, a transaction is an action or a series of actions in which it involves various operations. It performed by a single user to have various operations for accessing the particular content of the databases. Suppose we can take an example whenever an employee or whenever a person transfer a bank amount from one account detail to the another account. This is the transaction in which the various low level tasks are involved. So let's discuss how the transaction works and what are the processes or what are the operations in this. Let's, for example, if we are transferring a particular amount, for example, over here we have taken a 800 amount is going to transfer from X accounts to the Y account. So what are the several operations or the small task we involved in this? That is called as the full transaction series. So first what we have to do, first we have to open the account of a X account, then we have to fetch the balance. What is the balance? So that will be called as the old balance. For example, it will be having a 1000 rupees in the old balance, so it will be going to the old balance account. Now, if the person is transferring some particular amount, then it will be going to deduct or the add-on into the new balance. So, what will be the new balance over here? It will be old balance minus 800. For example, over here we was having a old balance was 1000. Now it is going to be deduct the 800 amount, and that will be called as the new balance. So now the X balance is equals to new balance. Now it is going to update it. So over here the X balances will be equals to 200. So this is how the several tasks is involved into the particular account. Now what is the transaction? When this particular information is updated into the databases, means this X will transfer the amount into the Y, then the X updated amount and the Y updated amount, that will be called as the full process and the series of operations, that is called as the transaction. Now talking about the Y account, what it will do again the task. What the task will be involved? It will open the account, that is called as the open account of a Y, whatever the balance will be there. For example, over here it is having a 2000 for example. So the old balance will be equals to Y balance, whatever the balance will be there, that is called as the old balance, that is 2000. Now what will be the new balance? He is going to transfer the 800 amount to this account. Now the new balance will be, that is equals to 2000 plus 800. Now it will be update. How it will be update? The new balance will be going to the Y balance. Now the Y balance value will be equals to 2800. This is how the balance updated. So this whole process is called as the transaction, in which we are going to transfer particular amount. So this is how then we have done the last task, that is the close account to the Y. Now there are the various operations of a transactions. Let's discuss about the various operations. First are the main operations are the read operation and the write operation. So what is the read operation? For example, read operations is used to read the value of a X from the databases. Means it will only read the value and stores in the buffer in the main memory. Okay. Now talking about the read operation, what is that? It is used to read the value, whatever the value we want to read from the databases. Now it will store it to the buffer in a main memory. It will not permanently store the values. It will for the buffering part, for the reading part, it will just store, and afterwards it will reverse back to the databases. Now, second operation is called as the write-x. Write-x operation is used to write the value back to the databases. For example, any updation we are doing, it will be going to update in the database on also. For example, we can take the last example also. Whatever the updations was there, it will not update into the databases. But in case of write-x, it will update into the databases. Means if we have transferred the X amount, X have transferred some particular amount to the Y, it will update into the database also. But in case of readx, it will not update. It will only read the values. We can't change the values in the databases. So this is the basic difference between the readx and the writex. What is the basic difference? That from there, we can only read the value, we can't change the value. But in case of writex, we can write the value and we can store that particular value into the databases. This is how we have done. Let's take an example to debit the transaction from an account which consists of the following operations. Let's take an example. So this is the Rx, whatever the value is there, we have read the amount. Okay. For example, we had just assumed that the value is 4,000. Whatever the value of starting amount is 4,000. Then what we have done? We have done 4,000 minus 500. Then we have done the write-x. So over here, what we are doing? Only we are reading the value. Whenever we will perform the wx or a write-x function, it will update the value or it will decrease the value into the databases also. Let's understand this whole example. We have taken the values of x before starting, that is the 4,000 amount. Then what we have done? The first operation is read x value from the databases. So it will read and stores it into the buffer. What is the second operation it is doing? The second operation is x is equals to x minus 500. Means over here what we are doing? 4,000 minus 500. Then it will be doing a second operation. It will decrease the amount of the x so that the buffer will contain the 3,500. Now, what is the third operation over here? That is the wx. What is wx? Now, it will write the buffer's value to the databases. So, in case of readx, it will not update into the databases, but in case of a writex, it will update the value into the databases also. So, the final value of x will be that is equals to the 3,500. Okay. Now, let's take an example. Now, it may be a possibility that because of the failure of a hardware, software or a power, it may be a possibility that the transaction may fail before it finished all the operation or all the task involved in the particular set. So what thing we can do in that particular case? So for that we are having two different operations. We are having the two different operations, that is the commit and the rollback. For example, if the in the above example we have taken the last example or a transaction in which the debit transaction fails after executing second operation. Means for example, from over here only the transaction got failed. So what we are going to do? Then the x value remain will be the 4,000 only. So which will be not be acceptable by the bank. So to solve this particular problem, we have the two different operations, that is the commit and the rollback. So what the commit will do? The commit operation will save the work done permanently. Whatever the work we have done previously till the second operation, what we have done, whenever we use the commit operation, it will save the work done permanently. For example, we have told that the after second operation it got failed. So what we can do over here, we can use the commit command or a commit operation. So what it will do? It will save the work. Whatever the work we have done, whatever the value additions we have done, for example 4,000 minus 500, the value will be saved. So this is how the commit operation works. Now what is the rollback command? It is used to undo the work done. Means whatever the work we have done, we can undo that particular work. For now, we can just we will do after the power backup. We will solve the problem, then we can do value the things. So the rollback command is used to undo the work done. Means whatever operation we have performed, we can undo the work done. This is how the rollback command works. Then we can discuss the various properties in the transaction. They are the various properties should be there to maintain the consistency in the databases before and the after the transaction. For example, whatever operations we are doing, whatever transaction we are doing, there are the several properties. To maintain the consistency in the databases, we have to follow some property of a transaction. So what are these properties? That is the atomicity, consistency, isolation, and the durability. So talking about these terms we have already discussed in the previous lectures. So we will just go through the briefly. Now, what is the atomicity is? It means either all, successful, or none. What it does mean? What atomicity tells that either all transactions should be successful or either none of them. Means either the transaction should be complete. For example, we have done a amount transferred from X to the Y. So it should be transferred the value from X to Y. If the transaction fails in between, so it will be not be considered. The values from one account and the another account should be updated, and it should be operated all. So this is how the atomicity works. It means either all or either all successful or none. What is the consistency? We will discuss these terms in detail also. What is the consistency over here? Consistency means it ensures the databases from one value, means it will ensures the whatever the value we have updated should be updated in the both the account. The value should be consistent, means the correct. Consistent, we can say that the value should be correct. Okay, so it ensures the value should be consistent in the both the states, in the both the account details. We will discuss through the examples also. Now, next term is isolation. Isolation ensures that the transaction is the isolated from the other transactions. Means the values are not updated into the both the transactions also. So these are the values in which the isolated from the other transactions. What is the durability is? It means a transaction has been committed, it will remain. It will save or it will be permanently stored into the databases. It will be the consistent value. So even in the event of errors or the power loss, the values will be stored safely or permanently. This is how the durability works. So let's discuss with the examples all these terms. For example, atomicity. Atomicity states that all the operation of a transaction takes place at once. If not, then the transaction is aborted. Means if the transaction fails, then it got aborted. In midway, it cannot occur partially. Okay, in the each transaction, it is treated as a one unit, either to run the completion or it is not to execute it at all. Means we have discussed already that it should be having either all successful or none. This is how it works. So it have the two operations, that is the abort and the commit. What the abort means? If a transaction aborts, then all the changes made are not visible. For example, we are having the several operation in between, the power loss or a error occurs. Then whatever the changes, if we will use the abort command or operation, then it will, whatever the changes we have done, that will be not visible into the databases. This is how the abort operation works. And commit we have already discussed before. What it does shows, means whatever operations we have performed, it will visible into the databases also. Means whatever the changes we have done into the operation or into a transaction, it will be visible to the databases. So if it will for example 1 2 3, we are having the several operations, so we have to run either all or either none. It should be like that. We can abort in between. If the transaction fails, we can use the abort command. If it is successfully running, then we are going to use the commit command. Now, this is how we have done this is the example. Similarly, that some T1 is transferring the amount to the T2. So A consists the amount of the 600 over here, and it consists the 300. So these are the various operations. Okay, we are reading the values of operations. Over here we have done the read the values, that is the 600. Then we have done the 600 minus 100. Then we have performed the write operation. Over here same thing we have done. These are the two different transactions. Over here what we have done, we had read the value of a B. Then we have done the add-on, means this particular A is transferring the amount over here. So over here what we are going to do, 300 plus 100, then we will final update the value. So after completion, in both the transactions, the value should be consistent. The value should be, it should be performed whole. So the value after the transactions, the value will be over here is 500 and over here it will be the 400. This is how it works. Now, the second property is, that is the consistency. Consistency means the correctness or the integrity constants, means it should be maintained into the databases. Before the transaction and after the transaction, the value should be updated. Before the transaction, what's the value, and after the transaction, whatever the changes we have done, it should be updated. It should not be showing the incorrect values or the inconsistent values. So let's talk about the consistency. The execution of a transaction will leave our databases in the either its prior stable state or a new stable state. Now, the consistent property of a database states that every transaction sees a consistent database instance, means it shows the value should be correct. Now, the transaction is used to transfer the databases from one consistent state to the another consistent example. Just understand the thing by the following example. For example, before the total amount must be maintained before or after the transaction. This is the function of a consistent thing. The total amount means whatever the amount will be before the transaction, it should be maintained after the transaction also. For example, before the transaction, it was 600 plus 300. So it was the 900. But after the transaction, it was again 500 plus 400. The amount should be same. This is how we can check the values of a consistency. Therefore, the database is consistent in the both the before the transaction, the values same to the after the transactions. So this is how we can check the values whether the database is consistent or not. In case whether the T1 is completed but T2 fails, then the inconsistency will occur. This is how we can check the consistency and the inconsistency thing. Then the third properties, that is the isolation. That is, the values should not be in between interchanges, or if the transaction fails in between, the value should be isolated from one transaction to the another transaction. It shows that the data which is used at the time of execution of a transaction cannot be used by the second transaction until the first one is completed. For example, we are having a several operation 1, 2, 3. So until the first operation is not performed fully, it will not operate the second operation. So this is how the isolation work, or the second transaction can is completed. In isolation, if the transaction T1 is being executed and using the data item X, then the data item can't be accessed by the another transaction. This is also the one thing, the values or the operations, or we can say that the data items using the particular values cannot be accessed by the another transaction until the transaction is fully completed. This is how we can use the isolation part. The concurrency control subsystem of the DBMS enforce the isolation property. Now, durability. The durability property is used to indicate the performance of a database consistent state. It states that the transaction made the permanent changes, means whatever the changes we have done, that is the permanent changes. In case of error operation or a system failure, it should not be the value should not be gone or lost. So they cannot be lost by the errorless operations or a system failure. When a transaction is completed, then the database reaches to the state known as the consistent state. That consistent state cannot be lost even in the case of a system failure also. So it will be used in the recovery subsystem of a DBMS. In the last case, the isolation is used in the concurrency control subsystem, or in case of a durability, it is used into the recovery subsystems. Means it is the property which will be showing the permanent changes. Now, there are the various states of a transactions. There are the several states. For example, the first state is called as the active state. Then we are having a partial committed state. If in case of a failed, it will go back to the failed state. But in case of the successful operation, then it will goes to the third state. Then it will be go to the end. But in case if it is got failed, then we are going back again to the active state. This is how it is work. Now let's discuss one by one about this. For example, it is going over here, then it will abort the thing. For example, the active state is the first state. This is over here, we are starting the transaction. So this is the active state. So this is called as the first state of every transaction which is being executed. We can use the insertion, deletion, or updating record over here, which can be done there, so that it cannot be over here. Whatever the operation we have done, it is not saved yet. Okay, means if we have done the insertion part, updation part, or deletion part, over here the performance just started. It is not saved into the databases. Now where it goes, then it goes to the partial committed state, where the transaction executes the values. Means if you have done the insertion part, it will execute the insertion thing. If you have done the deletion, then it will use the particular operation. But the data is still not saved into the database. In case of the partially committed state also, it is still not saved into the databases. It is into the mark of a calculation part. Means if it is some part or whatever the steps are there, it will be executed over here. Now, a transaction is said to be committed, is into the committed state. Wait a minute. This is the example over here. When it will be called as the committed, when it will be execute all the operations, whatever the operation is given. For example, there is a set of a 4 operation. So when all the operation will be execute successfully, then it will be called as the committed. So in this state, the effects will be now permanently saved onto the databases. Means whenever a transaction will come into the commit state, then only the values will be stored into the database system. Before that, it will not store the values into the databases. So a transaction should be committed. We have used the commit operations. So why we are using that particular commit operation? For the value saving part, for the storing the value permanently into the databases. In case of any checks made or any system fails or a recovery part, there is a failed state in which if any check made by the database recovery system fails, then the transaction is said to be the failed state. For example, some calculation part or any operation is not able to work or not executed, then it will be going to the failed state. Then it will be going to the abort state. This is how it will be work. In the example of total mark calculation, if the database is not able to fire a query to fetch the marks, then the transaction will fail to execute. Now, if it is failed, whatever the values we have done, whatever the operations we have done, in between it got fails, then it will goes to the aborted state. After the failed state, it will be going to the aborted state. Now, over here, what it does, it is reached to the abort state, then the database it is in the previous consistent state. If it will not update the value, it will not update the values into the databases. It will last whatever the values we have done, that will be into that consistent state. If the transaction fails in the middle of a transaction, then before executing the transaction, all executed transactions are the rollback. Rollback means whatever the values we have done, whatever the operations we have performed, that will be not saved. That will be go to the first consistent state. So after aborting the transaction, the database recovery module will select one of two operation, either the restart the transaction, either we have to kill the transaction. So these are the two operations under the aborted state. Either we have to follow whole the step, we have to start again from the active state, either we can kill that particular transaction at that particular point. Then we can start the values of the schedule. In this particular schedule, a series of operations from one transaction to the another transaction. Over here, we was discussing about the transactions only. Over here in the schedule, there are the multiple transaction, multiple series of operation from one transaction to the another transaction is involved. So that is called as a schedule. It is used to preserve the order of operations, that which order will be performed when. So this is how we are doing the schedule. Then there are the three type of schedules. That is the serial schedule, non-serial schedule, then the serializable schedule. We will discuss these things in the detail also. Let's discuss about what is the serial schedule. Serial schedule is a type of a schedule where one transaction is executed completely before starting the another transaction. In the serial schedule, when the first transaction completes its cycle, then the second transaction is executed. For example, we are having a series of operations. This is the T1 transaction. So after that only the T2 transaction will work. This is how the serial schedule works. So there are the disadvantages of the serial schedules also, that it will limit the concurrency. It causes the CPU wastage time because multiple transactions are not working at the same time. Smaller transaction may need to be wait long. For example, it will what is doing when that first transaction will work, hold the operation, then only we can perform the T2 transaction. So this is how the serial schedule works. Then we are having a non-serial schedule. We can use interleaving is applied. For example, T1 and T2, it can be used either it can be used, either it can be used. So it is called as the interleaving operations, means there will be a non-serial schedule. It can be used, T1 can be also execute its operation and T2 can be also execute its operations at the same time. It might be a possible orders in which the system can execute the individual operation of a transaction. There is a one disadvantages of this. It might be give sometimes an incorrect result sometimes. So this is the non-serial schedule in which the interleaving of operation is allowed. Then we are having a serializable schedule. It is used to find the non-serial schedules that allow a transaction to execute concurrently without interfering between the one transaction to the another transaction. It identifies which schedules are correct when the execution of the transaction have the interleaving of operations. So the disadvantages of the non-serial will be fulfilled over here. So this is how the non-serial schedule will be serializable. If it will result is equal to the result of a transaction executed serially. We will understand this concept in detail in the next lecture. Thank you, Jay.